So today's topic is Prim's algorithm. Okay. So this is another algorithm to find out the minimum spanning tree from the given complete graph. So question will be same, just the changes is that either it will be solved by Kruskal's algorithm or Prim's algorithm. Okay. So last day we discussed the Kruskal algorithm, and today we have to learn what is the algorithm of Prim's and what is the process. That means how to solve a problem. That means the complete graph will be given and we have to construct the minimum spanning tree. So here you can see Prim's algorithm build the minimum spanning tree by adding leaves. So every time obviously we have to add the leaves. Leaves means basically the edges. Okay, edges of that particular graph. So here we have to adding the leaves one at a time. Same for both Kruskal or Prim. But me here obviously they are a little bit different from the Kruskal. Okay. So now we start with a root vertex R. It can be any vertex because of this is a complete graph and we have to construct the tree, that is a minimum spanning tree. Okay. So root can be any one of them. That means from that particular graph, any node can be the root. Okay. So this indicates that we can start the process or the solution from any of the vertex from that particular graph. And now the third point is that at any time the subset of edges A form a single tree. So now just check it. The fourth point is while making MST, that is the minimum spanning tree, our graph is divided in S and V minus S set. Okay. So what is V? What is S? That is the question. The big question for this algorithm is how to decide a node from V minus S to include in S. Okay. So another way to find out the MST using Prim's algorithm is that, and this is the easiest way. So I think this is if I am a student, so I will follow this one. Okay. So this algorithm start with one node, any one, and then one by one, and then one by one edge, or the one by one node will be add. Okay. And that is unconnected to the new graph to the new graph each time selecting the node whose connecting edge has the smallest weight. So that means we have to start from any one of the node first. You have to select one node. That means one vertex will be select. Okay. And thereafter you have to find out from that particular vertex we can reach how many node. Okay. If we reach more than one node, if we reach only one node, that is we have only choice to select that way. Okay, that means we have to select that edge because we have no option. If there have more than one node, we can reach from that particular node to more than one node, then we have to choose the smallest weight, smallest weight. Okay. So what is the difference between Kruskal and Prim's? That is In Kruskal, all we first of all we have to create the age table according to ascending order of its weight of all the age. Okay, so that is a process. So that table is firstly we have to create that table. But here we first stand in a particular vertex, then we have to check how many node we can reach from that particular vertex, and thereafter we have to choose the minimum one. And this time we follow one queue, that is the priority queue, and that priority will be depend on the smallest weight. Okay, so when we solve the problem, so that time all the query will be clear within this class. Okay, so now next there is the steps. The new graph is constructed with one node from the old graph. So from the old graph, we will start from a particular node. Okay. Suppose there have six A, B, C, D, E. A, B, C, D, E, F, six node. So if uh, someone can start from A, someone can start from C, someone can start from F, someone can start from D, whatever. Anybody can start from anywhere. Okay. So starting node is does not matter. That should be particular. Okay. Then find the node from the old graph with the smallest connecting edge to the new graph. Okay. So that means we have to starting from a particular node and then we have to choose edge. That means smallest weighted edge. Okay. For example, suppose this is a complete graph. You can see all of you that is a given graph is a complete graph, and obviously that is not a spanning tree because there have first of all there have the graph is closed graph, there have cycle. Okay, and another rule that is the graph have more than n minus 1 edge. So if there have how many node, that is 5 and 5 10 node, that means 5 and 5 total 10 vertices is there. Okay, so that means we need to represent this graph with 9 vertices, sorry, 9 edge, then that graph will be that graph will be minimum spanning tree. Okay, obviously this that is a spanning tree, but if that all the edge represent the minimum weight, so that is called the minimum spanning tree. So first you have to choose any one of that. Okay, now we see where we will start from. So because of my name is Amartya, so I will choose from A. So I will choose from A node. Okay, and thereafter we have to think from A where we can reach. That is from A we can reach B and we can reach D. Okay, so B and D is directly connected with A, and the weight is AD weight is 1 and AB weight is 4. So now if we create a priority queue according to its weight, so minimum weight priority is high, maximum weight priority is low. So in this way we can say the AD, that is the weight is 1, obviously high priority, so it will be into the front position, and thereafter AB, that is the 4, the weight is 4, that will be smaller priority, so that will be after that. So first in our priority queue, first is 1, then 4. Okay, so by 1 we can reach D, by 4 we can reach B. So according to priority queue, the front positions, that is 1, indicates we have to draw the AD. So we just connect A and D. Okay. Okay, so A and D, between A and D, you just see, between A and D, we just connect D. First, we connect D, A and D. Okay, thereafter, we have to check from A and D. From A and D, where we can reach. From A, we can reach B, that is 4 is already within the priority queue. Right now, AD, the one is already deleted, and right now front is at the the front position, the new front position's value is 4, and that is indicate the AB. So next, when we already at D, so from D again we have to think where we can reach. So from D we can reach B, H and J. And what is the weight of this? The weight are 4, 5 and 6. So according to priority of weight, we have to insert 4, 5 and 6. 4 means basically B and D, and 5 means H, and 6 means J to connect. So now, because